Okay, we're asked to evaluate each expression. Well, we look here and we realize that we're dealing with absolute value. Remember, the absolute value works like a parentheses, but everything that comes out of the absolute value is positive. So let's see. The absolute value of -4 is positive 4. Positive 4 minus 3 is positive 1. So we evaluate and we get positive 1 as our answer here. Okay, so we want to know -4 times -1. Well, negative times a negative is a positive. So this really asks us for the absolute value of 4. Well, the absolute value of 4 is just 4. We get 4 when we evaluate this. We're evaluating, so we can write an equal sign. We're evaluating here. Okay, we're asked to graph the equation here, and our equation happens to have an absolute value. Well, why don't we make a table? That might be the easiest thing for us to do here. So let's go and make a table. Now, we're not given any specific x and y's, so let's use -3 to 3 for our x's. It's a good starting place. It doesn't mean that that's always exactly the window that we want. It just means that it's a good place to start. Okay, so if x is -3, the absolute value of -3 is 3. 3 minus 2 is 1. So let's put that point. The absolute value of -2 is 2. Well, 2 minus 2 is 0. The absolute value of -1 is 1. 1 minus 2 is -1. Just because we have an absolute value in the problem doesn't mean our final answer is positive. Only what comes out of the absolute value is made to be positive. Overall, we can still have a negative like we do here. The absolute value of 0 is 0. 0 minus 2 is -2. The absolute value of 1, well, that's easy. It's already positive. It's 1. 1 minus 2 is -1. Okay, 2 minus 2 is 0. 3 minus 2 is 1. We have our V shape. Remember, absolute values make a V shape. We're going to continue the pattern as far as our graph will hold it. Let me erase my little stray mark there. Okay, it's an equal, so we're going to make our solid line. There you have it. We have our absolute value graph. Okay, this is supposed to read old material, so let's cross that out and fix it. This is the previous material. Old material, previous material. Either way. This should look familiar as it's been on several tests in the past. Okay, we see parentheses and we see a number outside the parentheses. So that means we need to distribute. We could make generic rectangles, but we don't have to. We can just draw our arrows and distribute. So -5 times -6, a negative times a negative is a positive. So I'm going to have positive 30 here. -5 times positive 5p is going to give me -25p. Now I have to be careful right here. I have a negative 3 that I'm distributing. So I have negative 3 times 5 is negative 15. And I have negative 3 times a positive 7p, which is a negative 21p. Okay, so now we need to combine like terms. 30 minus 15 gives me 15. And negative 25p minus 21p gives me negative 46p. So my final answer on this problem is 15 minus 46p. Okay, here I'm actually solving. So again, I have to distribute since I have a number outside of a parentheses. Again, I'm going to be careful because it's a negative 5 that I'm distributing. I'm going to go ahead and bring down my negative 1. And I have negative 5 times 1 is negative 5. Negative 5 times a positive 6n. Well, a negative times a positive is a negative, so negative 30n. And this is all equal to 174. So now I'm going to combine like terms. Of negative 1 minus 5 is negative 6 minus 30n is equal to 174. Well, let me just add 6 to both sides. That gives me negative 30n is equal to 180. Then I'm going to divide both sides by my coefficient of n, which is negative 30. Tells me that n is equal to negative 6. So how did I do that? I just take away my 0. How many times does negative 3 go into 18? Negative 6. N is equal to negative 6.